Assalamu alaikum. I am Syed Jawad Akhtar along with my partner Hussain Hadar Zaidi. Under the mentorship of Rashid sir, will be giving my presentation on deep reinforcement learning on AUVs and how we did it. So the outline of my PPT will be starting with some theory about starting with the introduction of AUV, the motivation goal of our project, and the basics of about reinforcement learning and the optimization policy that we'll be using. And then my friend will be talking about the different simulations that we are doing and the results we got at the end. So an autonomous underwater vehicle, or also known as an unmanned underwater vehicle, is a device or a machine that actually performs its tasks underwater without any human assistance. It follows a specific task as programmed, and it is normally used for reducing the cost of scuba divers and going to the places where humans cannot go. It uses different sensors and different thrusters to actually perform the tasks and interact with the environment. The main application of AUVs are to perform different surveillance missions. It is also used for mapping the seabed, and it is majority it is used in the defense purposes as well. The main motivation of our goal was to dive into underwater robotics, as this is a new and challenging area, and new research is being carried out in this field. And we thought that our model can also be used in underwater surveillance for various purposes. The main objective of our project was to simulate and program a complete AUV using different simulators, implement machine learning techniques, and successfully detect and flag underwater cracks and save marine lives. A basic understanding about reinforcement learning is that it's a task performed by an agent. It's an action performed by an agent in an environment, and in return, it gets an observation and rewards. And on this rewards and observation, it tries to optimize its action, and it does this until it achieves its target in the environment. The policy that we will be using in this is the proximal policy optimization, and it is used mainly because it minimizes the cost function while ensuring the deviation from the previous policy and is relatively very small.
So to implement our AUV, the reinforcement learning on our AUV, we considered many simulators, out of which we chose Unity Game Engine. This game engine provides us a platform to create 3D models as well as program behavior using the C# scripting language. It also has a newly released plugin called ML Agents, which allows us to train to put the observations of the agent and create its behavior. ML Agent also gives us many examples through which we learned how to program the environment, the agents, how to give it sensory input, as well as some basic examples of what rewards we should set for our AUV problem. So moving on to the star of our project, the AUV, we modeled this in Unity. It consists of four bidirectional thrusters placed as such, which gives it around 4 degrees of freedom. We have also constructed a pool with a small red ball in the middle. Now, as an agent needs some input from the environment to learn from, we are currently giving it a set of 27 values, which becomes 9 vectors, which consists of various velocities at different thrusters, the total velocities, as well as vectors which are in the direction towards the target or with respect to the vehicle. So the goal of our AUV is that it should navigate itself to touch the red colored buoy. Now, to reinforce this goal, we are giving it rewards at every time step of the game, which is around 1 by 60th of a second, as the game is running at 60 frames per second. So, at each time step, for locomotion tasks, ML Agent has recommended that we give a small positive input, positive reward when it's moving towards the goal, and a small negative reward if it's moving away from the goal. So, likewise, we have set the given rewards for training. Some other parameters include we reset the position of the AUV at a random location every 3,000 steps. This helps it become helps it learn a more general uh, behavior. as well as the architecture of our neural network consists of two layers, 512 neurons. We had trained the AUV agent for around 50,000 steps. So let us demonstrate. Here is a video of our AUV while it's being trained. This is a sped up version. As you can see initially, because the model has learned nothing, it's giving off random velocities at each of the thrusters. So you can see the erratic behavior of the AUV while it's training. But soon afterwards, when we completed its training, now this is the video of the agent actually inferring from its trained model and navigating in real time. So you can see on the top right corner, the reward is increasing linearly, as well as the agent is moving towards the ball finally so that it can touch and complete its goal. So in our we have here some graphs of our training. In the initially our reward was negative, but as it increased, our reward came to the positive side. And as the AUV was reaching the goal quickly, the episode length decreased as we increased training. Here are some graphs from our policy. We can see that the estimated reward each episode kept on increasing as we increase the training, as well as due to our algorithm, the learning rate decreases linearly as we increase training. So next phase, we will be implementing different algorithms, such as PPO, as we have done right now, and comparing it with other reinforcement learning algorithms like SAC. We will also be checking how well the AUV performs if we are giving it some camera sensory input. So that was our project. Thank you very much.